Okay, so let's do some more practice covalent bonding with the Lewis dot structures. Okay, first we're going to do CO2, carbon dioxide. Now, there are 2 oxygens and there's only 1 carbon. So you know carbon's going to go in the middle and oxygen is going to go on either side. Now oxygen has 6 electrons. Let's go back to the periodic table and look. Now see, here's oxygen, and oxygen is in group 6A. So you know oxygen is going to have 6 valence electrons in it. So here's oxygen. We want to put 6 valence electrons. 1, 2, 3, 4, 5, 6. Because you always want to have 4 going around first before you start doubling up. 1, 2, 3, 4, 5, 6. And carbon, here's carbon. Carbon is in group 4A, so carbon's going to have 4 valence electrons around it. So 1, 2, 3, 4. We can plainly see that there's a bond, there's going to be a bond between the oxygen and the carbon valence electrons right there. You just got to connect the dots. And now we have this bond right here between carbon and oxygen. We have this bond on the left between carbon and oxygen. But look, oxygen still has a free one over here, and carbon still has a free one over here. Now these slide down into the middle, in between the 2 elements. Here's one for oxygen, here's one for carbon, and you can draw a line in between them. And look, here's one up here. Here's a lonely electron for carbon that can go meet in the middle to join up with the other ones. Here's a lonely one for oxygen that'll meet up in the middle, and that'll create a bond right here. So let's redraw this so it's not so messy. We got oxygen, and we have carbon and the other oxygen over here. Now let's do the circle test. If you draw a circle around the oxygen, including the bonds, we're going to count the dots. So there's 1, 2, 3, 4, 5, 6, 7, 8. So does that solve the octet rule for this oxygen? Yes. So we have 8 valence electrons now in oxygen. Let's try over here for this oxygen. We have 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 valence electrons for oxygen. And let's do carbon. So carbon goes around, including the bonds. So carbon has 1, 2, 3, 4, 5, 6, 7, 8. Now carbon has 8 valence electrons around it. So let's rewrite this. And there you go, there's carbon dioxide, CO2. Alright, let's try another one. Now let's look at H2CO. Now carbon is going to form the most bonds with H2CO because carbon has the most lonely electrons. Because here's carbon all by itself. So see, carbon has 4 lonely electrons. They're all alone on either side of carbon. So if carbon has the most lonely electrons, then carbon's going to go in the middle. And then you're just going to put the one hydrogen on either side of the carbon and an oxygen on another side of the carbon. Now let's draw the 1, 2, 3, 4 that carbon has. And we remember from the periodic table that oxygen has 6. 1, 2, 3, 4, 5, 6. And hydrogen has 1. And remember, hydrogen is an exception to the octet rule. Hydrogen only wants 2 valence electrons in its shell because it's so small. So that's a duet rule. So hydrogen only wants 2 electrons around it, as opposed to everything else. Everything else wants 8 electrons around it. So with hydrogen, all we have to do is connect the dots right here, and we have our bond. Now with oxygen, here's a dot right here, and here's a dot for carbon. All we have to do is connect those dots. But look, it leaves a lonely electron up here and a lonely electron over here. So these guys scooch down to where it would make sense to bond. So here you go. And this one scooches over so they can bond. They can form a bond because they're attracted to each other. So that's going to move them over. So now we have something that looks like this. Let's rewrite it. So now we would have carbon would have a double bond right there between carbon and oxygen, and the hydrogen and carbons would have a single bond. Now let's do our circle test rule and draw a circle around these. Now remember, hydrogen only wants 2 electrons. It doesn't want 8, but everything else wants 8. So here's hydrogen. Does it have 2? 1, 2 dots. Yes, it has 2. And let's draw one around hydrogen over here. 1, 2. So that has 2. Now let's draw one around carbon. So carbon has 1, 2, 3, 4, 5, 6, 7, 8. So carbon has 8 electrons around it in its valence shell. And let's do oxygen. Here's oxygen. So oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So oxygen has 8. So does that satisfy the octet rule for all of these elements except for hydrogen, which has a duet rule? Yes. So it's going to look like this. And there you go. Now we knew to put carbon in the middle because if you look at carbon, carbon has 4 lonely electrons that need to be paired up. Now oxygen only has 2 lonely electrons that need to be paired up. So that's how we knew that carbon went in the middle. Whoever has the most loneliest electrons that need to be paired up goes in the middle. Okay? So that's why we knew to put carbon in the middle. Otherwise you'd get something like this. But that wouldn't work because the oxygen and the carbon and everything, the bonds wouldn't work if we did that. So carbon needed to go in the middle. Okay, let's try something else. Let's try nitrogen. Nitrogen 2. So that means we have 2 nitrogens. Alright, now let's look up the periodic table. Here is nitrogen right here, sandwiched in between the carbon and oxygen. And nitrogen is in group 5. Because see this 5 Roman numeral? I wrote over it, but that's a 5. So nitrogen is going to have 5. So first we put 1 around each side. 1, 2, 3, 4. And then we put a 5th one. And I'm going to put it as far away from the others as possible because we don't need to pair either one of those. So same thing over here. 1, 2, 3, 4, 5. Now, between the nitrogens, it's just a matter of connecting these dots. But then look, we have a lonely electron here and a lonely electron here. So these are going to fall into the middle, in between the 2 nitrogens, and they're going to bond right there. But look, we have another set of lonely electrons up here. These are both going to fall into the middle, so nitrogen can share them, and they're going to go right there. So now look, we have 3 bonds in the middle now. So this is what would be called a triple bond. Now let's do the circle test. Nitrogen had 5 and we need 8. So 1, 2, 3, 4, 5, 6, 7, 8. That works perfectly. And the same thing over here. 1, 2, 3, 4, 5, 6, 7, 8. So it satisfies the octet rule. Oct just means 8. Like an octopus has 8 legs. So octet rule of having 8 electrons around it. So that would be nitrogen. Now let's try another one. Let's try water. H2O. So there's 2 H's and there's 1 O. So the O is going to go in the middle. So the H's can go on either side of it. Now each H has 1 electron. And the O, the oxygen, has 6. Right? Let's go back and check on the periodic table and make sure. Here's the O. And it's in row 6 or column 6A. So that's 6. So 1, 2, 3, 4, 5, 6. And I just randomly put the double electrons up here and the double electrons down there to make it easier, because we know we're going to need these in the middle between hydrogen and oxygen for bonding purposes. So it's just kind of random. I just put them there to make it easy. Now here's the hydrogen and oxygen, and we can connect those. Here's the hydrogen and oxygen, and we can connect those. And now that's it. So let's do a circle test. So here's hydrogen with its bond. That's 2 electrons, 2 valence electrons. That satisfies the duet rule for hydrogen. 2 electrons, 2 valence electrons for hydrogen. And then here is oxygen. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 valence electrons for oxygen. So that's perfect. So what we got here is, and that's H2O, water. Okay, let's do one more. Let's do NH3. These are common problems that you might find on a test. So NH3, there's only one N and there's 3 H's. So you know N's going to go in the middle. And then I'm going to put an H out here to the side, an H out here to the side, and then an H just in on the bottom here, on the bottom side. Now N, if you remember, here's N, and N's in group 5. So N has 5 valence electrons around it. So 1, 2, 3, 4, 5. And then hydrogen has 1 electron, so 1, 1, 1. Now we can just connect the dots. It's really just a matter of connecting the dots. Here's a dot to a dot, here's a dot to a dot, there's a dot to a dot. Alright, now let's do the circle test. Here's hydrogen, and that gives it 2 valence electrons. That satisfies its duet rule. Here's hydrogen, and that's 2 valence electrons. That satisfies the hydrogen's duet rule. Here's 2 valence electrons. That satisfies hydrogen's duet rule. And here's nitrogen. So 1, 2, 3, 4, 5, 6, 7, 8. So now nitrogen has 8 valence electrons around it. So that satisfies the octet rule for nitrogen. So nitrogen would just be and that's it. And that is covalent bonds written in the Lewis dot structure.